Have you ever wondered how a car engine works?
Thermodynamics!
We will prove the first law of thermodynamics by using a homemade piston with a thermometer.
Ta-da!
Thermodynamics is a branch of science concerned with heat and its relation to other forms of energy and work. The first law of thermodynamics states that the change of internal energy equals the heat added to the system minus the work done by the system.
First, we filled our homemade piston with 50 milliliters of water. This permitted us to prove the first law of thermodynamics by controlling the variables of temperature, mass, specific heat to have as a result the change in internal energy. What we did with this was that we heated up the bottom part of the decanter with water inside, and the water vapor would make the piston rise.
There isn't much difference between our homemade piston and a car's. During the process of a car piston, a small explosion takes place inside a chamber to pump the piston up, where in our experiment, water is heated up inside a decanter to pump our piston, the syringe, up.
Now, how is this applied in real-life thermodynamics? When a piston, whether a car's or ours, is shut up, there is some work done on it, while at the same time there is heat applied either by combustion or evaporation.
As you can see, when heat is added, the piston rises, therefore proving the first law of thermodynamics.
This process was repeated various ways with different ways and a more controlled environment to be able to prove and analyze the data of how the thermodynamics work on our piston. Now, work is force times distance times cosine of the angle. We had to measure the distance that the piston rose to be able to calculate the work. We built in this small box to be able to put the masses on top of the syringe, using mg as the force for the work.
The temperature in the outside was of 30 degrees, and we tried to raise to 70 degrees always for a constant change in temperature of 40 degrees Celsius.
Using the law of thermodynamics and by replacing equations, constants, and combining like terms, we were able to make a y-intercept equation between the variables. Then, we made a graph using this equation between the change in distance and 1 over mass. The graph proved the hypothesis and the law of thermodynamics because it had a positive and almost constant slope.